Hello, my name is Kevin Constant. I am with Topeka Electric Motor in Topeka, Kansas. We are the Midwest distributor for Cool Blue inductive absorbers. We are actually here at the ESA convention in Toronto, Canada, 2016 at the Cool Blue booth. We're going to show you today how Cool Blue cores work, and by removing bearing parasitics as well as common mode currents on the T-leads. First, we have just a standard motor that has been heavily modified. You can see here, the end bells were the motor was disassembled. The end bells were bored and bushed oversized with Delveron bushings. The reason why this was done is we wanted to totally insulate or isolate the rotor from ground. We do want no circuit between ground and the bearings. As you can see in the next photo, there was a small wire that was actually soldered to the outer race of the bearing. This is so we can measure the bearing current from the shaft to the inner race, through the grease layer, to the ball, to the grease layer, to the outer race, and then to ground. Now, we are going to start up our motor on a static drive to represent what standard three-phase looks like without the use of frequency drive. What we have is a static phase converter. The motor has now been started. We actually have a Rogowski coil that is tied to the wire on the back of the motor through the bearing. This Rogowski coil measures the common mode current on the T-leads. As you can see on the screen, the red line represents the red. The red line represents the opposite drive bearing. The blue line is the common mode currents. This is on a static phase converter. We know we didn't used to have bearing problems with electric motors because of our signal was clean. We were going to shut the phase converter off. I'm going to reconnect and actually hook to the frequency drive without the Cool Blue cores installed. As you can see, the amount of parasitics that is now traveling through the bearing to ground is quite intense. This is what causes the electrical discharge machining, which causes the frosting and fluting damage to an electric motor ball bearing or conveyor system or gearbox, however it's coupled. We also have, on this motor, we have a shaft grounding brush. We can also hook it up, and as you can see, there has been no change in our readings, none whatsoever, on the effects of what shaft grounding brushes do. I will unhook this, nope, stay focused. I will unhook this and you will see that there is no difference. Readings did not change. So, that being said, I will now shut the drive down. I will rehook the drive to the leads that do have the Cool Blue inductive absorbers on them. I will restart the drive. As you can see from the screen, the reduction of the amount of bearing parasitics and the amount of common mode current that is on the T-leads. I will also now demonstrate you can actually shunt the Cool Blue out to simulate them not being in the circuit. I will shunt them out, and you will notice by shunting them out, it cancels out their effectiveness, and now you can see that the parasitics and the common mode currents have returned. I am going to unhook the shunt wire, and you can see how it all dissipates. This is the advantage of using Cool Blue inductive absorbers to help with longevity in electric motor ball bearings. It can also be used for EMI currents, voltages. And this is our presentation today, and thank you.